Hi, this is Nirmala Rednam. In this video, we are going to start the topic Rational Numbers from CBSE NCERT textbook class 8. You're already familiar with natural numbers, whole numbers and integers. In this chapter, we are going to discuss the definition of rational number and the different properties of rational numbers. So if you look at the introduction, you will see that we have been given a few simple equations in one variable, right? The aim here is to make you realize that if we stick to natural numbers or whole numbers or even integers for that matter, we might not be able to solve all equations. So let's look at the first equation. X plus 2 equal to 13. You will see that x equal to 11 will satisfy this equation, right? Now what is 11? It is a natural number, okay? Now, the knowledge of natural numbers was sufficient to solve the first equation, right? But if you look at the second equation here, x plus 5 equal to 5. Now, this can't be solved using natural numbers, right? You need whole numbers where we include the element 0 to natural numbers. Now, if I put x equal to 0 here, I am going to get the solution. Okay. Now if you look at the third equation, which is x plus 18 equal to 5, you will see that again whole numbers is not sufficient to solve this equation. I need negative numbers. So when I put x equal to minus 13, I will get the solution. That means the solution lies in the set of integers. Now coming to the last two equations. You will see that these two equations cannot be solved using integers as well. Now if I put x equal to 3 by 2 in this equation, what is my LHS? 2 into 3 by 2. Now I can cancel this here and this is equal to RHS, which is 3. So the solution is 3 by 2. Now let's look at this equation. 5x plus 7 equal to 0. I put x is equal to minus 7 by 5 and try to see what the solution is going to look like. This is nothing but minus 7 plus 7, which is equal to 0, which is my RHS. So again the solution is a number minus 7 by 5. Now what are these numbers? 3 by 2 and minus 7 by 5. These are nothing but rational numbers. Now coming to the definition of a rational number. What do you mean by a rational number? Let us look at the definition, right? So, rational numbers. Okay. Any number that can be written in the form of P by Q. Any number that can be written in the form of P by Q. Where? What are these P and Q? P and Q are integers. These are integers. But, and very importantly, Q is not equal to 0. Okay. These numbers are called rational numbers. So what are rational numbers? Any number that can be written in the form of P by Q, where P and Q are integers and Q is not equal to 0 is a rational number. You can see in the name itself, it is about ratio, right? P by Q. Okay. Now let us move on to the properties of rational numbers. The first property that we are going to discuss is the closure property. So here we are going to look at the definition of closure property and we will quickly recall the closure property in whole numbers and integers and then move on to rational numbers. So what is the definition of a closure property? For a given set S under a given mathematical operation, we say that S is closed under the mathematical operation whenever for any AB belonging to S, A operation B belongs to S. Okay. Now, let me repeat this. We say that a set S is closed under a mathematical operation if for any A B belonging to the set S, A operation B also belongs to the same set. Okay. Now what is this S? You are already familiar with the set of natural numbers, set of whole numbers, set of integers and set of rational numbers, which is denoted by capital Q, right? And what is this mathematical operation? You know that we have 4 mathematical operations: addition, subtraction, multiplication and division. Now let us discuss in detail each one of these. That is, how, under what operations is the set of whole numbers closed, under which operations is the set of integers closed, and under which operations is the set of rational numbers closed, right? So let us put the heading closure property. Closure property. So I am going to consider the set of whole numbers. So let me write down the mathematical operations: addition, subtraction, multiplication and division, right? Now if you look at the definition, I need any 2 elements A, B, right? Now let us take any 2 elements in the set of whole numbers, let's say 3, 5, right? Now what is A operation B under addition? That is nothing but 3 plus 5. Now what is 3 plus 5? 8. Does this element belong to the set of whole numbers? Yes. So you can say that whole numbers is closed under addition, right? Now if you look at subtraction, you will see that 3 minus 5 is minus 2, which does not belong to the set of whole numbers. So you can conclude that whole numbers is not closed under subtraction. Now if you come to multiplication, I have 3 into 5 is equal to 15, which is a whole number. So you can say that whole numbers are closed under multiplication. Now coming to division, 3 divided by 5 is not a whole number. So you can conclude that whole numbers are not closed under division, right? Now we will move on to the next set, which is a set of integers. So if I have integers, I am talking about closure property, right, for the set of integers. Okay. So I have the set of integers here, and let us take the mathematical operations: addition, subtraction, multiplication and division. Now let us consider any 2 integers. Okay. Let's say I will take minus 3, 5. Now if I add these 2, minus 3 plus 5, what do I get? 2, which is an integer. Therefore you can say that the set of integers are closed under addition. Now if I consider the subtraction of this, minus 3 minus 5, which is equal to minus 8. Is this an integer? Yes, it is an integer. So you can conclude that integers are closed under subtraction as well. Whereas in the case of whole numbers, we have seen that whole numbers is not closed under subtraction. Now when it comes to multiplication, minus 3 into 5 will give you minus 15, which is an integer. Therefore you can conclude that integers are closed under multiplication. Now coming to division, let us look at this. Minus 3 by 5. Now is this an integer? It's not an integer. It does not belong to the set of integers. So division is integers are not closed under division, right? Next, coming to our rational numbers. Again, let's put the heading closure property. take any two rational numbers. Okay, I have set of rational numbers. Now I am going to consider the 4 mathematical operations, right? Now take any two rational numbers. Here, for example, I am taking minus 3 by 5 and 2 by 7, right? These are two rational numbers. Now if I add these two rational numbers, let us see what happens. Minus 3 by 5 plus 2 by 7 is going to be, how are you going to solve this? I need to take the LCM here. 5 and 7, the LCM is going to be 35. And here I have minus 3 into 7 plus 2 into 5, right? This is how you will add two rational numbers, right? So now this is nothing but minus 21 plus 10 by 35, which is minus 11 by 35. Now is this a rational number? Yes, it is a rational number. Therefore, we can conclude that rational numbers are closed under addition. Now when it comes to subtraction, let us see. Minus 3 by 5 minus 2 by 7. Again, the LCM is going to be the same. Here I am going to have minus 3 into 7 minus 2 into 5, right? So this is nothing but minus 21 minus 10 by 35, which is equal to minus 31 by 35. Now is this a rational number? Yes, it is in the form of p by q, where p and q are integers, q not equal to 0. So this is a rational number. So we can conclude that rational numbers are closed under subtraction. Okay. Now coming to multiplication, our rational numbers are minus 3 by 5 and 2 by 7. There is nothing that gets cancelled, so I simply am going to write it as minus 6 by 35. Now is this a rational number? Yes, it is. So I can conclude that rational numbers are closed under multiplication. Now coming to division. How do you divide two rational numbers? Minus 3 by 5 divided by 2 by 7 is nothing but minus 3 by 5 into 7 by 2, which is equal to minus 21 by 10. Now is this a rational number? Yes, it is. So can I conclude that rational numbers are closed under division? Now here I would like to bring to your notice that whenever a statement has to be proved, you need to make sure that it is true for any AB belonging to S. Now clearly it is practically impossible to check for all the possibilities because there are infinite possibilities given a set, right? Given a set of rational numbers. Now, but in order to disprove, that is to, if I have to prove that rational numbers are not closed, one counter example will be sufficient. True? Now here you will see that if I take the second element as 0, okay, leave the first element as it is. If I take the second element as 0, you will see that minus 3 by 5 divided by 0 is not defined, okay, and it does not belong to the set of rational numbers. So you need to conclude here that rational numbers are not closed under division solely because of the element 0. Now if you were to exclude 0 from the set of rational numbers, then this new set is closed under division. But set of rational numbers as such is not closed under division. Okay, so this is about closure property of rational numbers. Now let us look at what is given in the textbook. They have given in the table format the whole numbers. We have already concluded whole numbers are closed under addition, not closed subtraction, closed for multiplication, not closed for division, and so on. As we have done, they have taken few examples and they have checked for it, right? Even for integers, they have done the same thing. They have taken few examples and they have concluded. When it comes to rational numbers, again they have taken a few examples. You can go through that and they have concluded closed under addition. You can see here it is closed under addition, right? and it is closed under subtraction, the set of rational numbers, and again it is closed under multiplication, right? And here if we take 0 as a second element, we see that rational numbers are not closed under division. However, if we exclude 0, then the collection of all other rational numbers is closed under division, right? So here there is a small try these exercise that has been given to us, where they are asking us all these 4 operations for these 4 sets. We can quickly fill this up. For the set of natural numbers, it is quite similar to whole numbers, the exception being only one element, that is 0, right? So natural numbers are closed under addition. Natural numbers are not closed under subtraction. They are closed under multiplication, and they are not closed under division. When it comes to whole numbers, we have already done this. Addition is a yes, subtraction is a no, multiplication is a yes, and division is a no. When it comes to integers, addition is a yes, subtraction is a yes, we have seen it. Multiplication also is closed, and for division it's a no. Rational numbers, we have seen it's a yes for addition, subtraction, multiplication as well, and division. We have seen there is one exception of 0 where it is not closed, because of which it is not closed. So with this we come to the conclusion of this section of closure property. I hope it is clear to you now what is the meaning of closure property and how to check whether a given set is closed under a given operation. Now in the next video we will be covering commutative property as well as associative property.